Fabulous. Okay, so when we have Apurv Sheth coming on next, Apurv is going to be talking to us about design considerations for GraphQL. This is actually something my architects and I were talking about yesterday, so I'm going to take some notes. And Apurv, you're from JP Morgan, so welcome, and the stage is yours.
Yeah, thanks a lot, Apurv, and thanks for having me here. All right, so to start with my introduction, so today I'll be speaking regarding the GraphQL design approach. So we have heard a lot of around the GraphQL, how to implement, what all are the different approaches, what all the design considerations we need to make. So today we'll go through this GraphQL design approach. And to give the little bit of my introduction, so my name is Apurv Sheth, and I'm working as an AVP at JP Morgan Chase, and I'm very code junkie and passionate travel and the book lover. So that is a short, brief introduction about me. So let's dive into the GraphQL design thing. So our agenda would be we'll go through the GraphQL, what is GraphQL and why it was introduced, a little bit of history about the GraphQL and current trend with respect to the REST. We have RPC and different sort of communication mediums via which the REST or the HTTP protocol we are using. So we'll go through a little bit of trend, then the existing problem with REST and the other HTTP way of communication, and and after that we'll go through the solutions spotted by the GraphQL and the approach, whether the code first or the schema first approach. So this is our agenda for today, and let's dive into the GraphQL. So whenever it comes to the QL, query language, right? So we always think that it has to do with relational database or something like that. That we have to write a query, and then we'll fire the query, and there will be an engine running in the background which will return us the records. So the last part is quite similar, but here let's make sure that it is a query language, but it is not the SQL or anything to do with the relationship modeling. It is just the GraphQL query language where it will return us the records, but not via database, but via the HTTP protocol, and it helps us to define the structure or the response rather, where GraphQL is giving a freedom to the consumer end. So let's say, for example, if we are having the REST API, and in case of REST API, we are having the response, and in that response, if something is missing, then what we'll do is we will change the response model. But here, in case of GraphQL, what will happen is with a single query, without having any of the new endpoint introduced, we can fetch the data with the same GraphQL query. So when we talk in terms of the query language, right? So it is the API that is very declarative in data fetching, and it gives the power to the client. So when I say power to the client, so here client choose what fields or attributes they want, but not the predefined set of attributes, right? So based on the different requirements, it may happen that we have to keep on writing the new APIs. But here, in the case of GraphQL, probably single API is sufficient enough. And as I mentioned, it is not the SQL. So let's not worry about the relational, let's not worry about and think about the relational database or anything of that sort. So it has nothing to do with that. And so to put it in a perspective, it is not a replacement for REST. So it can coexist. We can use along with the REST as well, and in the sidelines. So we can use GraphQL at the same time we can use REST as well. So definitely it's not a replacement, but yeah, depending on the different scenarios, what are the scenarios that we can analyze and can decide what exactly GraphQL provides and how we can achieve the functionality which we want to achieve via using the GraphQL. So let me discuss something about the history. So it all started way back in 2010 and was created by the Lee Baron. So basically, it was internally being used as a tool in Facebook, within Facebook organization, and then as it grows and matures enough, then it moved to the open source during 2015. So still, it was not generally available, but then down the line, it evolves further. And in June 2018, it was released and with a stable version. And it moved out from the Facebook, and it was moved to the GraphQL Foundation, and that is the non-profit Linux Foundation, right? And today, I mean, we have so many companies using the GraphQL, and companies like Pinterest, GitHub, Shopify, and all. So those companies and many more, meaning those companies are pretty much using the GraphQL very extensive way. So this is regarding the little bit of history. So as I mentioned earlier, right? So if you will see the trend since 2010, right? So 2010 is where the GraphQL was kind of introduced and came into the market. And if you can see the blue line over here, during 2010 until 2015 or so, uh, there was not much inclination towards using the GraphQL, but then it picks up from 2015 once the stable version gets started and launched. Then it moved in a good pace where developers started using the GraphQL. So if you'll see, if you'll go through this trend, right? So uh, the orange line, which is nothing but the RPC, and the yellow line, which is nothing but the rest. So if you'll see the trend, right, the blue line, which is the GraphQL, which is picking up since 2015 till now, and if you'll see the trend from 2015-16 around, the trend of using the REST API as a HTTP protocol, right, to have the HTTP communication. So it is declining a little bit. It is declining day by day. So as I mentioned earlier, it is definitely not a replacement. Both can coexist with each other. But yeah, it all depends on the scenario and the approaches which we are planning to use. So, in general, and to conclude regarding the trends, yes, GraphQL is coming into the limelight, and developers have started using it via different applications, and they are using it in a very extensive way, knowing the functionalities GraphQL provides. So now let's discuss something about the problem. So when I say problem, right? So usually in our day-to-day life, what we are using is most likely the REST or the RPC. So when it comes to the GraphQL, so first let's discuss about the existing problem, what all problems we are facing in our day-to-day life, and we'll discuss few scenarios, and then we'll get to the solution, that how GraphQL usually helps in mitigating those issues. So, so if you will see, right, why GraphQL was introduced. So way back in 2010, there was a very drastic spike in mobile usage. So if you'll talk in terms of 5 to K year and all, at that point in time, there was very less usage of mobile applications or mobile data. And network wise also, there were very less data speed we were getting at that point in time. And as we progresses further, so towards the end of the 10, there was a drastic spike in the mobile usage. But at the same time, the services which provides the APIs, they were not able to cope up with the network which we have at that point in time, or the devices were not that powerful, which supports the data communication within across the network. So since there was a spike, right? I mean, in mobile usage starting from 2010 till now, if we can see, it's exponential growth in the mobile usage, and hence the different front-end frameworks and platforms was introduced. So if you think in terms of 2010, during 2010 we have very less number or types of devices, like hardly the mobile, and that too big in size. We were not having that. Many number types of devices, but today if you'll see, we have different types of devices like iPad, as I can show it over here. we have the desktops, we have mobile devices, notebooks, and wearables, and many more other types of devices. So if we are using the REST API, right, then the issue is that for each and every type of APIs, we'll have to support those respective devices to support those platforms. So let's say, for example, if I'm using the mobile, then my API, I will have to write an API which requires a minimal data, which consumes very less resources, and with the minimal data, the consumer can see the required data only, but not the full details of the data, or not the drill down of the data, right? So the problem was due to the spike in the mobile usage, the sloppy networks, and the low power devices. uh, APIs were not able to, I mean, we will have to keep on shifting our focus on supporting the different set of devices. So hence the GraphQL introduced, and we will see down the line that since it is introduced, how it mitigates the issues which we have discussed just now, with respect to the mobile usage, with respect to the different devices it supports, or with respect to the network, how it dealt with these issues, and how it helps to mitigate all these issues with different scenarios. So now let's discuss few of the use cases. So as I have given you the brief in the past slides, right? So there were a few issues where data, we have to pass the data across the network for the different set of devices. So we have to implement the different set of service API services. So let's say, so now let's discuss, when I talk in terms of the different APIs to support the different set of devices, or with respect to the network, then how what all problems we may face. So consider that we have a replication. For example, we have a replication where we have to display the latest blog posts on the UI, and to achieve that, what we have to do is we have to get the posts, all the posts, latest posts via the REST API, for example. So let's take the REST API in this case to get the post for the latest blog post, right? So the program would, or our API would look something like this. What we'll have to do is we'll have the REST endpoint where API/post is the endpoint, which will return us all the list of blog posts which are latest, and which has the attributes as in title and subtitle, right? Now let's say, for example, in this use case, so to put it at a high level, I have one API which is returning me the data, and now what if I need the data which is not already there as a part of that API, right? So in this case, let's say if I want to get the authors out of out of the existing API which I have. So for example, this API post REST endpoint is returning title and subtitle, but it is not returning the author's detail. So now there are three different scenarios which we can think of. So we'll get into those scenarios, that what all the possibilities which may have to get the authors out of the API. All right. So let's consider the scenario first, right? So if I need an author from the endpoint, then how I can get? So first I'll get the blog post, and along with the blog post I'll get the author ID or something, and based on that I'll get the author details. So in that case, what I'll have to do is I will have to fetch the author from the another resources, right? So I will have to write down brand new resource where I will have the another set of APIs and backend implementation, where I will expose the new APIs, and it will return us the authors for that blog post. So what will happen? I mean, to summarize, in this scenario, we will end up calling the two different APIs, one for the for getting the latest blog post, and second to get the author details for that respective blog post, right? So that result in underfetching that existing API which we have, that is not providing us the required data, And second, we have to write a new API. Since the existing API doesn't returning us the required data as an author in this case, so it results in an underfetching. So think about this, meaning as system grows, right, then what will happen? So how many each endpoint like authors, there may be something else like publications, for example. If you want along with the blog post, who all are the publications, right? So what we will, and if it is case of underfetching, then we will end up having the n number of REST endpoints for different requirement, which which we may not be able to scale at large, and that results in an underfetching, right? So that is the one scenario where it results in an underfetching with the existing API, and we'll have to write a brand new REST endpoint. Now let's consider the second scenario. What might be the case? So other scenario is we can modify the existing resource, right? So as initially I show you that we have one scenario where we have the API. So if you can see that we have the API right here. So this endpoint is very same. So what we can do is we can introduce the author's attributes as a part of the response in the existing API itself, and can expose that attributes to the consumers, right? So what we can, the different the this use case is to modify the existing resources where we will have the same endpoint exposing the set of attributes required by the consumer. So it resolved the issues definitely and very nicely. There is no issues in that because we are not changing the REST endpoint, and we are introducing the new set of attributes with the existing endpoint itself, and we can continue our development, right? But the problem is, what will happen, let's say for example on my desktop, I want authors only on my desktop UI or interface, but when it comes to the mobile or the low latency device, I don't want the author. So even though I don't want the author on mobile device or any similar portable devices, then in that case, what will happen is even though I don't want the authors, I will end up getting the authors. Where in that case, network also will be impacted, the low latency device also will be impacted, and the memory impact is huge on the low latency device. So what will happen is, so the thing is, if same resource is being used for different micro front ends, since we are living in era of the micro front ends or the BFF, backend for front end, then in that case, what will we might end up is having the overfetching, where even though I don't want any data for respective devices, then also I end up getting those data, which is not the good case. Because if we'll talk in terms of the mobile device, even though I don't want, then why there should be any impact on the memory or the network or in the overall API as an API endpoints, right? So first scenario we discussed on the underfetching. Second scenario we discussed on the overfetching, where even though we don't want the data, then also we continue to get those data. And third one is to create a new resource which returns the post with its respective authors, right? So what will happen is, if we'll keep on creating the new resources as I mentioned earlier, then what will happen, meaning front end will be, if so whichever team involves in the front end development activities, they will have to wait until the new API endpoints keep on introduced. So for example, in this case authors, so until unless this new API endpoint, if you can see here, this API slash get post with authors, right? So with this API endpoint, a UI development team will have to wait until this endpoint is ready, which may slow down which may slow down the development of the front end UI, right? Because they will have to they need a specific endpoint, they will have to wait until the backend uh, backend team provides those APIs, right? So it results in a very slow front end development. So to summarize now, three scenarios we discussed, right? One is the underfetching, where we are not getting the author's detail. Second scenario, overfetching. Even so, if you will introduce the new attributes as a part of the response of the existing API, then it may result in the in overfetching of the result set. And the third scenario which we have seen is where the new API endpoints will be introduced by the backend team, where the front-end team will have to wait until those API endpoints are ready, and which may impact the overall development of the front-end UI. So now, after having discussed all these three scenarios, right, overfetching, underfetching, and slowdown of the performance, let's now jump into the solution. How GraphQL help us to resolve this issue, right? So to put it in a simple way, right? So GraphQL comes to the rescue, right? So what it provides is we will have the single query. You can see here we will have the query where we can get all the latest posts, and we have different set of attributes where title, subtitle, date, author, those all attributes we can get easily. And so what exactly we are achieving here? So here, if you can see that title, subtitle, date, author, so those all attributes, right? It is consumer driven, or rather client driven. So whatever attributes I want, let's say if I don't want author, I will not get these attributes using the same single query. So it is client or consumer centric, and there is no impact or change we have to do from the backend API service perspective. So here, if you can see, right, that single query without impacting the application, there won't be any impact on any other API endpoints or the backend of the application APIs or anything. Just simply, we will expose the required attributes, and consumer can get any of those attributes which are required. So here we are solving the underfetching, we are solving the overfetching, and we don't, or the front end development team doesn't need to wait until the brand new endpoint introduced. So it can give the power to the client to fetch the needed data only. So let's say for mobile device, I don't need this author. Okay, so while calling this API, I will not get this author as an attribute, and I will get only the title, subtitle, and date. For example, then for computer or desktop, I need an author, so I can simply just put that author attribute in my query so that I can give authors for the desktop application, right, or desktop APIs. So all those three scenarios which we discussed are GraphQL helping us to resolve those issues, and as well as it will not impact from the network perspective, from the low latency mobile device or any sort of portable device perspective. It will help us in development activity also, to fasten up the development activity as well. So if you see, so now if we see the old way, where we have seen that we have to introduce new endpoint or the change existing endpoint and all, and the new way of implementing it, how it resolve this issue, right? So these all three scenarios which we have gone through, which I have just now explained. So if you can see that this underfetching, right, where author is not required, but still it is there. And another scenario where the brand new endpoints we are introducing, and uh, front end team will have to wait until then. And the another scenario where it results in an overfetching, where even though I don't need, but still I'll keep on getting those attributes. So if you can see the GraphQL query solution over here, so here this author, for this we are using the API posts endpoint. For the underfetching scenario, we were getting the separate endpoint for the authors. And this third scenario where we were having the brand new endpoint where it is returning the author, right? But here, if you'll see, with respect to the GraphQL, we are having a single query, and using this single query like posts, and using this post I can choose whichever attributes I wanted to use. right? So here title, subtitle, and date. So whichever attribute, like for example, if author I don't need it, then probably I will not choose that attribute. So there is no change in the backend API, there is no change in the backend logic, and there is no dependency in case. So assume that if there is any dependency on this API, any of this API, a REST API, right? Then what will happen? If we are changing one of the API, then it may impact the other APIs as well. Whereas in this
Hey,
case,
Apurv.
yeah,
Sorry, we are running out of time. If you want to wrap it up quickly,
yeah,
please.
sure. Yeah. So yeah, so this is how this GraphQL with a single query we can mitigate all these scenarios. So now let me quickly, since we are running out of time, probably I
Uh,
will quickly.
Actually, we have run out of time.
Oh,
Sorry,
all right.
I
Oh,
was
okay,
sorry. I was
okay.
giving you a 30-second heads up there,
All
but
right, all right.
that's right.
Yeah, sure.
Are
So
we okay to pause here, or
yes, just quickly, 2 minutes. Let me just quickly discuss the just 2 minutes only, not more than that.
I can give you
So
30 seconds if
sure,
you want
sure.
to
I'll
discuss
wrap
there,
that up.
right? Yeah.
Yeah, sure. So yeah, so GraphQL, we can implement GraphQL with two different approach: schema first and code first approach. So I will not get into all these details, but at eye level, in schema first approach, we have to write a schema, and based on that, GraphQL will get those schemas and query the data. Whereas in code first, we don't need to write any schema, and even in any programming language, whosoever also doesn't know the GraphQL can directly use the code first approach where we can play around with the annotations. So to where to go from here, we have to, so we can look at the GraphQL Apollo and GraphQL Federation, which we can use as API gateway for the GraphQL API. So for any aggregation or any sort of that logic, if you want to implement that, then we can use the GraphQL Federations or GraphQL Apollo. And recently Netflix also has introduced the DGS, with that also can be used. Yep, Akhil. So I'm
Fantastic.
good to, yep. And
Cool. Thanks,
I'm
Apurv.
sorry for
And
running out of time, but it's really a huge topic, but to cover in a minimal time. Yep. So I'm open
it
for the
is,
questions. Yep.
yeah. Look, we might have to skip the questions because we have
Yep.
run
Yep.
a couple minutes over time, and I want to be courteous to the
All right.
next speakers as well.
Sure.
But thank you so much. GraphQL is super exciting. I've been in this space for 3 or 4
Right.
years now, and
Right.
I think a great primer on it.
Exactly. Yep. Yep.
Cool.
Thanks a lot,
Thank
Akhil,
you
for
very much,
having me
Apurv.
here. Yeah. Thanks, everyone. Yep.